right, good morning. Today we are going to talk about domain and range of a continuous relationship or a relation. A continuous relation is one that can be graphed as a smooth line or a curve because the domain can be all numbers. It is not limited to whole numbers. When the relation is aligned, we can't list values because we would have to list every single decimal. That's an impossible thing to do. We can use inequality notation to show all the possibilities. Okay, so inequalities, we talked about this when we were solving inequalities. We have greater than or equal to, less than or equal to. Okay, we use the greater than or equal to sign if it's a filled in dot and it goes to the right. Okay, we use the greater than or the less than or equal to sign when it's a filled in point and it goes to the left. But it's just greater than if we have an open point and it goes to the right, and then just less than if it's opened and goes to the left. Okay, so the rules still apply when it comes to greater than, less than, equal to versus greater than and less than. Okay, if there's an open endpoint, it's just greater than or less than, depending on what it is. All right, so let's look to the graph on the left. It has two endpoints. One is at -7, 4. I know it says that, so it's -7, 4. And then the other is at 4, 9. So again, little error right there. Okay, when the domain can be written. So remember, we talked about this in our last video when it comes to discrete. When we're on a graph, it is left to right when we're talking about domain. Okay, and it's based off of the x-axis. So remember, our x-axis is this one right here. And the furthest left that my graph goes is at -7. And the furthest right the graph goes is at 4. Okay, so the domain can be written as -7, 4. If you can label the endpoints, guys, notice how our x values are the domain's numbers that we're using. We just always put the smallest number first. Okay, so the smallest number was -7, so -7 went first in our function, our notation right here. The domain values are between the values of the x coordinates. So just like what I explained, it's the smallest value goes on the left and the largest value goes on the right. Because of the endpoints of our graph are included, they are filled in circles. That's what that means. We use the less than or equal to and greater than or equal to sign. Okay, try writing the domain or the range. Okay, what this is saying right here, this right here, is that x is between -7 and 4. So the range, remember, the range is from bottom to top. So the most bottom this graph gets is at 4. Okay, so 4 will go here. And the most top it gets is at 9. So again, notice how it is your y coordinates, and it's always the smallest number that goes first, and then the largest number goes on the right. Okay, and what this is stating is that y is between 4 and 9. All right, look at the graph on the right. What do you notice that's different from the previous graph? You should notice that our most bottom point is not included. Okay, there is an open endpoint. Okay, so what that changes is the sign that we'll use. Okay, so when we are graphing inequalities, an open endpoint would mean that we would use our greater than or less than sign, and then a closed circle goes to the greater than or equal to and the less than or equal to sign. So on one of the points, we're going to use the greater than or equal to, less than or equal to, and then the other point is going to be greater than or equal to. So we just have to be careful on which signs we use, because on this one, we will use both. Now write the domain and range of this. Okay, so remember domain, left to right. Okay, or you can plot the points. So I'm going to do both. Okay, so this point right here is at -6, 4. Make that a little bit darker. And this point is at 6, -6. Okay, so our domain, I'm going to highlight in pink. Our left, our most left it gets is -6, which is our x value of the first point on the left. And the most right it gets is at +6, which again is the first coordinate of the most right point we have. Okay, so when we write this domain and range, -6 will go on the left, 6 will go on the right. Because domain talks about our x values, x will go in the middle. Now, the hardest part, determining if we use an open or our greater than or less than or greater than and equal to, less than or equal to. Okay? As long as our smallest point goes first, our inequalities will always face the same way. So it's always going to be open to the x on the first one, but close to the x on our last number. Now we just need to decide which one uses a greater than or equal to. Okay, so since the -6 is with the point that is closed, the -6 gets the equal to sign underneath. And that's our domain. Our range, remember, is bottom to top. So we're going to go to the most bottom this point gets, which is -6, which again is our y value. So that goes first. And then the most top this point gets is at 4, +4, which again is our y coordinate of our top point. So then it's -6, y is in the middle, 4 is to the right. And again, our inequalities always face the same way. But now we must determine which one gets the included point. So the one that gets the equal to sign with it is the one that's with the closed end point, which is a 4. So 4 gets the less than or equal to sign. Okay. Another type of graph you may see may look like this. What do the arrows on the ends of the graph mean? This means it goes on forever. Okay, so is this a discrete or continuous graph? Well, since it is a curved line, it is continuous. And since the graph goes on forever, it will cover all x values. So notice how the graph will keep going. It'll keep going to the left, 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 left forever. And it'll keep going to the right, 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 right forever. So the domain of this one is all real numbers. Okay, because our domain just keeps going to the left and it keeps going to the right. So I'm just drawing arrows. The range is a little different. Because our graph has a maximum point but no minimum, the range is all less. Our range is all numbers less than or equal to 4. So notice how the graph does have a maximum point and it's at 4. Okay, so because range is y, we need to just determine, okay, which way does our inequality go? Well, because 4 is the highest this graph gets, our alligator mouth, which is what I like to call it, opens to the 4, and it includes 4 because it hits 4 completely. Okay. So because it starts at 4 but goes forever and ever down, y is less than or equal to 4. Okay, because the graph is below that 4. All right. All right, this is the last one I'll do. Let's put the two together now. Okay, look at the graph on the right. What is the domain? So remember, domain, left to right. Okay, where does it begin? Where does it begin? Well, it begins at -4, but notice how it's an open endpoint. So it's open. Okay, where does it end? This arrow tells us it doesn't end, so it goes forever and ever to the right. So this means our domain, which is x, is all numbers greater than -4. And it's only greater than because it's an open endpoint. Okay, and it's going to be greater because anything to the right of a number will always be greater than the number it starts on. Okay. All right, range. Where does it begin? So remember, range is bottom to top. Okay, well, it begins on -3. And again, it's open. Okay, and it keeps on going up, 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 up. Forever because of this little arrow right here. So because it's above that number, y is going to be greater than -3. And it's greater than because of the open endpoint it has. All right. I want you to try this one. The answers will be in the completed notes. Bye, guys.